Hello everyone and welcome to The Explainer. I am so incredibly pumped about today's topic because we are taking what is arguably the deepest journey ever imagined. We're going to explore the hidden, gigantic metal heart spinning deep, deep inside our planet. It's this massive subterranean structure that literally powers our magnetic shield and, frankly, makes every single form of life on the surface possible. I want you to just imagine for a second passing through solid rock, through massive underground oceans of magma, to reach a place that is hotter than the surface of the sun. It sounds totally like science fiction, but it is 100% real.
So, to kick things off, let's look at how far down we humans have actually gone. 12.2 kilometers. That's the Kola Super Deep Borehole, which holds the record as humanity's deepest hole ever drilled. Now, you might hear 12.2 kilometers and think, wow, that's a massive achievement, but the drilling had to be completely abandoned. Why? Because the deeper they went, the more hostile the Earth became. They hit extreme heat, immense crushing pressure, and their drilling equipment literally started melting. The rock down there didn't even act like normal rock anymore. It behaved more like warm plastic.
And this brilliantly illustrates what is probably our greatest physical paradox when it comes to studying the Earth. Humanity's deepest hole, at 12.2 kilometers, that represents only about 0.2% of the total distance to Earth's center. To get to the very middle, you'd have to travel a staggering 6,371 kilometers. We have barely scratched the thinnest, outermost layer of our planet's skin. The actual core remains completely and utterly inaccessible to us.
Which immediately brings up a massive curiosity gap, right? If no human has ever reached it, and if literally all our probes melt or get crushed before they even make it a fraction of a percent of the way down, how on earth do we actually know what is down there? Well, this is one of the greatest detective stories in human history. Decades of brilliant scientific research had to solve a massive physical mystery without ever seeing the evidence directly.
Section 1. Seeing with earthquakes.
Since scientists couldn't just drill down to look at the core, they had to become planetary detectives. And to do that, they needed a tool that could pierce straight through the entire globe. It turns out, the planet itself actually provides that tool every single time the ground shakes. As you probably know, earthquakes send out huge ripples of energy called seismic waves, rippling all the way through the Earth. There are two vital types of waves you need to know about here: P waves and S waves. Think of P waves as the all-terrain vehicles of seismic energy. They can travel through both solids and liquids. But S waves, they have a very strict physical rule. They can only travel through solids. And that one simple difference is the ultimate key to unlocking our planet's deepest secrets.
Now, what's really interesting is how scientists use that physical rule. They set up seismic detectors all over the globe, and they quickly noticed a massive shadow zone. The S waves, the ones that can only move through solid rock, remember, completely disappear when they hit a certain depth. They just vanish. Poof. Meanwhile, the P waves don't vanish, but they suddenly slow down and bend. Through pure scientific deduction, this wave behavior proved beyond a shadow of a doubt that deep within the Earth there is a massive layer of liquid, which we call the outer core, surrounding an incredibly dense, solid inner core.
Section 2. Inside the metal heart.
So now that we know how we've mapped the unseeable, let's explore the actual structure and the sheer massive scale of these layers beneath our feet. I know we all remember the classic giant peach analogy from grade school science, but visualizing it really does help us grasp the crushing proportions we're dealing with here. The crust that we live on is just the very thin, fuzzy skin on the outside of the peach. Right beneath that is the thick, soft flesh, which represents the mantle. And smack in the center is the hard, dense seed, which is the Earth's core.
Let's just wrap our heads around the scale for a second. The crust, where literally all of human history has taken place, is a mere 70 kilometers deep, and it maxes out at a toasty 700 degrees Celsius. Right below that is the mantle, stretching way down to 2,900 kilometers. This is made of hot, solid rock that very slowly flows over millions of years. This is actually the stuff that moves our tectonic plates around. Then, things get pretty extreme. We hit the liquid outer core, reaching depths of over 5,100 kilometers and temperatures up to 5,500 degrees. And finally, right at the center, is the solid inner core, plunging down the 6,371 kilometers and pushing temperatures up to a blistering 6,000 degrees Celsius.
And what exactly is that giant seed made of? Well, this massive subterranean sphere is intensely metallic. It's about 85% iron, 10% nickel, and 5% other elements like sulfur, silicon, oxygen, carbon, and even a trace of hydrogen. And I really want to emphasize the sheer size of this thing. The total core diameter is roughly 6,960 kilometers. To put that into perspective for you, Earth's core is nearly the entire size of the planet Mars.
just sitting down there inside our own planet. It's absolutely wild.
Oh, and it is unimaginably hot. The inner core reaches approximately 5,700 degrees Celsius. That is an awe-inspiring scale of heat. Just think about this for a second. The center of our planet is almost exactly as hot as the photosphere, the glowing surface of the actual sun.
But wait a minute. We established earlier that the outer core is a swirling ocean of liquid metal, right? But as you go deeper into the inner core, the temperature rises. If the outer core melts at a lower temperature, why on earth is the hotter inner core a solid ball of metal? It seems totally backwards, doesn't it?
Well, the answer is 3.6 million atmospheres of pressure. As you go deeper into the Earth, both the temperature and the pressure rise. In the outer core, the heat is high enough to melt the iron. But by the time you reach the very center, the weight of the entire planet bearing down creates such immense, crushing pressure that the iron atoms are literally forced into a solid structural lattice, completely despite that sun-like heat.
Section 3. The Giant Shield Generator.
Let's move along and see how this builds into something even more incredible. We're shifting from what the core is to what it actually does. This hidden structure isn't just sitting there being hot and heavy. It literally builds our planetary defense system in a process known as Earth's giant dynamo. Step 1, that incredibly hot liquid iron in the outer core is constantly moving and churning around. Step 2, because these metals are electrically conductive, this constant movement generates massive electric currents. Step 3, this flowing electricity generates the Earth's magnetic field. I mean, every time you look at a compass and see the needle point north, you are watching a direct reaction to an ocean of liquid metal churning thousands of kilometers below your feet.
And the dramatic stakes here could not be higher. What if that liquid core just stopped moving? Well, without that magnetic shield generated by the core, deadly solar wind from the sun would strip away our atmosphere entirely. Our satellites would suffer catastrophic radiation damage. Countless animals that rely on magnetic fields for natural navigation would be completely lost. Ultimately, life on Earth as we know it would become incredibly difficult, if not utterly impossible. Make no mistake, we owe our survival to that churning metal heart.
Section 4. Golden Secrets and Origins.
As we enter the final chapter of our explainer, let's talk about how this remarkable core formed in the first place and some of the truly mind-blowing treasures permanently locked away inside of it. About 4.5 billion years ago, the early Earth was basically just a chaotic, molten ball of rock. During a process called planetary differentiation, gravity acted on this molten planet. The lighter, rocky materials naturally floated upwards to form the crust and the mantle. Meanwhile, all the incredibly heavy, dense metals sank right down to the center, pooling together to create the core. And what's super cool is that it's still a dynamic system. Recent studies even suggest that this inner core rotates at a slightly different speed than the surface of the Earth, meaning its motion changes over time.
Now, because of this heavy metal sinking process 4.5 billion years ago, scientists estimate a truly staggering fact. Are you ready for this? Over 99% of all of Earth's gold is permanently locked inside the core, along with massive quantities of platinum and iridium. Let me say that again. There is enough gold down there to literally coat the entire surface of our planet. But because it's thousands of kilometers deep and under millions of atmospheres of pressure, it's going to forever remain completely out of our reach.
Which leaves us with one final, profound question. Earth is continuously losing heat to the freezing vacuum of space. Will this gigantic metal heart eventually cool down, freeze solid, and shut off our magnetic shield forever? What happens to our planet when the dynamo finally stops? Definitely something to think about the next time you look down at the ground beneath your feet. Keep wondering, keep exploring, and I'll catch you in the next explainer.